Let's get started on Chapter 10, TCP/IP, configuring IP4 and IP version 6 addressing. In this chapter, we will look at TCP/IP, IP addressing, testing TCP/IP, review of binary math, subnetting, public and private IP addressing, the dynamic host configuration protocol, automatic private IP addressing, IP version 6, and transitioning to IP version 6. So before we really get rolling on this chapter, let's just do a bit of a review of TCP/IP. TCP/IP, we say it as if it is one single protocol, but actually TCP/IP is two protocols. TCP/IP includes the IP protocol, the Internet protocol, which is used for sending packets and routing packets. And it is made up of the TCP protocol, the transmission control protocol, that is responsible for sending acknowledgments, negative acknowledgments, and flow control. IP sends a packet and TCP sends an acknowledgment. And together, TCP/IP provide communication between computers. Let's look at TCP/IP. If I go to Start and click on Control Panel, and then I select Network and Internet, and I select the Network and Sharing Center, and I select Change Adapter Settings. If I select my Ethernet card, right-click and select Properties, we can see there is the Internet Protocol version 4, TCP/IP version 4, and the description shows that the Transmission Control Protocol, Internet Protocol, is the default wide area network protocol that provides communication across diverse interconnected networks. If we look at the properties for TCP/IP version 4, we will see that this computer has an IP address of 10.0.0.1 with a subnet mask of 255.0.0.0. All computers must have an IP address in order to communicate. An IP address is a number which is assigned to a computer, and it is written in dotted decimal notation, such as 10.1.2.200. And each one of these values is called an octet because it is made up of 8 bits. In IP addressing, all computers must have an IP address in order to communicate, and it is our job as technicians to assign IP addresses to the workstations and servers. So let's look at manually assigning IP addresses to computers. I have 3 computers here, and what I want to do is assign the first one the IP address of 10.0.0.1, and then I will give the next one the IP address of 10.0.0.2, and as you can imagine, the next one will have an IP address of 10.0.0.3. So to do that, I click on Start, and I go to Control Panel, and I select Network and Internet, and I select the Networking Sharing Center, and I select Change Adapter Settings. I go to the Ethernet card, right-click and select Properties, and under the TCP/IP Protocol version 4, I click on Properties. And then here, I can type in the IP address. In this example, it's 10.0.0.1. And then I assign the next computer 10.0.0.2, and then the next computer would be 10.0.0.3. We will talk about subnet mask later. Duplicate IP addresses. Whatever you do, don't give any 2 computers the same IP address. If you do, you will get this error message that indicates that there's an IP address conflict, and then neither of the 2 computers will work. Now let's look at the situation if we have multiple networks. Here's our original network, and then let's say we add another building or another floor to our building, and we put the computers in there, and that's the additional network, and then we connect the new two networks together with a router. And the question is, what is the IP address going to be of this computer here? Well, if this one here is 10.0.0.3, couldn't we just make this one on the next network 10.0.0.4? We can't make it 10.0.0.4 because that violates the rule of any two networks having the same IP address. This is network 10 right here. So this has to be a network which is other than 10. So in this example, I will make it workstation 11.0.0.1, and then the next workstation will be 11.0.0.2 and .3 and so on. Now, I didn't mention this, but you also have to assign an IP address to the router, because a router is a device with two network interface cards. One network interface card goes to each network. So the Ethernet cards themselves need IP addresses. So what I will do is I will make the router 10.0.0.1, and then the first workstation will be .2, and the next workstation will be .3, and next workstation will be .4. We like to make the router .1 just for convention. You don't have to, it's convenient that way. And then the other network interface card would be 11.0.0.1, and the first workstation would be .2, and the next workstation would be .3. So this introduces TCP/IP addressing rules, which you can kind of figure out by just looking at it. In the same subnet, all host computers should have different host IDs. So this is .2, .3, and .4. And in the same subnet, all host computers should have the same network ID. So all of these computers begin with 10, and all of these computers on the other network begin with 11. And no two networks should have the same network ID. Let's now talk about the subnet mask. If we look at the IP address, we can see the IP address, and right below it is the subnet mask. The purpose of the subnet mask is to tell us which portion of the IP address is network ID and which portion of the IP address is host ID. If there is a 255 under the octet in the IP address, then that indicates that that octet is network ID. If there is a 0 under the octet in the IP address, then that indicates that that octet is host ID. So if we simply have a subnet mask of 255.0.0.0, that tells us that this is network 10, host 0.0.2. So let's look at this example. If we look at this IP address, it's kind of obvious that it's network 10, workstation 2. But if we look at this example, it's not really clear which part is the network ID and which part is the host ID, and that's the purpose of the subnet mask. This is what we would call a Class A subnet mask. If there's a 255 under the octet, that means it's network ID. So in this example, this is network 1, workstation 1.1.1. Now, in the next example, with the subnet mask of 255.255.0.0, that indicates that it's network 1.1, workstation 1.1. And in the third example, we have a subnet mask of 255.255.255.0, a Class C subnet mask that shows us that the first three octets are network ID and the last octet is host ID. So what we have here is network 1.1.1, workstation .1. If we look at the subnet mask in this example, a subnet mask of 255.0.0.0 indicates that the first octet is network ID and the remaining three octets are host ID. But if we look at this example, we can see a subnet mask of 255.255.255.0, and that tells us that the first three octets are network ID and only the last octet is host ID. A class A, B, and C network is identified typically by the default subnet mask. A default subnet mask of 255.0.0.0 indicates a Class A network. There are only 126 Class A networks, but boy are they big. 16 million potential hosts in each Class A network, something like Department of Defense. And at the other end of the extreme, we have a Class C network with a subnet mask of 255.255.0. The first three octets are network ID, and the last octet as host ID, and you have only 254 potential host IDs because there is only one octet which is being used for host ID, and as you know, an octet is made up of a total of 8 bits. Class A, B, and C networks. Now let's discuss what's meant by the default gateway. When we configure TCP/IP, we configure IP address, subnet mask, and default gateway. This has a default gateway of 10.0.0.1. The default gateway is the router that connects us to the outside world. For workstation 10.0.0.4, the default gateway for this computer is the IP address of the router, which is 10.0.0.1. If workstation 10.0.0.4 were to send data to workstation 10.0.0.3, well, then it would simply send the data to 10.0.0.3. However, if workstation 10.0.0.4 were to send data to a computer which was not on the same network, then that packet would be sent to the default router. The default router is the way the computer reaches the outside world and the internet. So when we configure IP address, subnet mask, we also configure default gateway. We will talk about DNS in the next chapter. So in TCP/IP, we configure each computer for an IP address, subnet mask, and default gateway. Now let's look at testing TCP/IP using the ipconfig command and the ping command. If we go to the command prompt and we type ipconfig and press the enter key, that will show us what our current IP address is. I press the enter key and I can see that this computer has an IP address in this example of 10.20.12.206. There's a subnet mask, and that's the default gateway. ipconfig simply shows you what the current configuration is. Now the ping command is used to determine whether or not you can communicate with another computer. When you ping another computer, you send a signal to the other computer. If the signal comes back, you know the computer is up and running, and you know all the cable between you and the other computer is good. So if I go to the command prompt and I type ping followed by the IP address of another computer, and I get a reply from that other computer, that tells me that the other computer is up and running and all the cables between me and the other computer are properly connected. The ping command tells me whether or not I can communicate with another computer. So in this review, we have discussed what's an IP address, a number which is assigned to a computer for purposes of communication, and that an IP address is written in a dotted decimal notation such as 10.25.3.252, and each one of these values is called an octet. An IP address is made up of the network ID and the host ID, and the way you can tell the difference is by looking at the subnet mask. The default gateway is the router, and we can test TCP/IP using the ipconfig command and the ping command. And this concludes part 1 of Chapter 10.